On a remote island in Indonesia, scientists observing Komodo dragons expected to witness one of nature's most efficient predators in action. These giant lizards, the apex predators of their environment, are known for their precision, patience, and deadly efficiency. But what unfolded during this particular observation left researchers stunned, rewriting what we thought we knew about predator behavior. Komodo dragon, instead of attacking its usual prey, made a series of choices that were baffling, and the consequences were both unexpected and shocking. Tonight, we explore this extraordinary event, the ecological insights it revealed, and the lessons it teaches us about nature's complexity and unpredictability. The day the scientists arrived setting the scene, the sun was just beginning to rise over Komodo Island, painting the rugged landscape in shades of gold and orange. A team of scientists, equipped with cameras, notebooks, and drones, had arrived early, determined to study the Komodo dragons in their natural habitat. These massive reptiles, often exceeding 10 feet in length and weighing over 150 kilograms, have long fascinated biologists due to their role as apex predators. Observing their hunting behavior offers a rare glimpse into evolutionary mastery, predator-prey dynamics, and the delicate balance of ecosystems. The scientists had carefully selected a location where deer and wild pigs, the usual prey, were known to graze. Each team member was acutely aware of the risks. Komodo dragons are not only powerful predators with serrated teeth and potent bacteria in their saliva, but they are also surprisingly fast over short distances, capable of sprinting at speeds of up to 20 kilometers per hour. Safety protocols were stringent. Multiple observation points, elevated platforms, and escape routes had been meticulously planned. The researchers understood that witnessing a hunt could be as dangerous as it was enlightening. As the team waited, they observed the typical signs of predator activity: flattened grass, droppings, and tracks indicating the passage of multiple dragons. The tension was palpable as the scientists speculated about which individual might appear first and what strategies it would employ. Komodo dragons, unlike many predators, rely on ambush techniques, blending seamlessly into their surroundings until the moment of attack. The team knew that patience was essential. A single misstep could mean losing the perfect observational window. Or worse, endangering a researcher. Hours passed with little action. Then, in the distance, movement was detected. A massive Komodo dragon emerged from the underbrush, its muscular body gliding over the terrain with a terrifying grace. The researchers' excitement surged. They were witnessing one of nature's most formidable hunters in real time. Binoculars focused, cameras recording. The team prepared for the usual scene: the dragon stalking a deer, coiling for the strike, and demonstrating the predatory perfection for which its species is known. But what happened next was unexpected. Instead of targeting the deer grazing cautiously nearby, the Komodo dragon changed direction, moving toward an entirely different animal. This choice perplexed the scientists immediately. The animal in question was smaller, less threatening, and, in the dragon's usual predatory logic, an unlikely choice. Whispers and notes passed among the team. Some questioned whether the dragon was sick, distracted, or displaying an unknown behavioral anomaly. Others speculated that environmental factors, wind direction, scent trails, or the presence of humans, might have influenced the decision. The researchers were entering uncharted territory. Every second of observation now carried potential insights into Komodo behavior that textbooks had not yet documented. The anomaly raised fundamental questions. How flexible is the Komodo dragon's hunting strategy? Can they adapt to unexpected opportunities in real time, even if it contradicts their usual predatory instincts? And most importantly, what would happen next? Would the dragon succeed, fail, or reveal an entirely new aspect of predator behavior that had never been recorded? The unexpected chase. Komodo dragon's strange prey choice. As the Komodo dragon shifted its attention to the unexpected target, the scientists could hardly believe their eyes. Instead of pursuing a deer or a wild pig, the typical mainstay of its diet, the massive predator moved toward a much smaller animal, a monitor lizard that was sunbathing near the rocks. On paper, this choice seemed irrational. Komodo dragons are known for their efficiency. They expend energy strategically, choosing prey that offers the highest caloric reward for the least risk. Attacking a small, agile monitor lizard presented almost no nutritional gain, yet it posed a challenge in terms of speed and unpredictability. The team quickly adjusted their observation equipment, capturing every move on cameras and binoculars. The dragon's approach was deliberate. Its muscular legs propelled it silently, and its forked tongue flicked rapidly, tasting the air and tracking the scent trail of the lizard. The scientists began taking detailed notes. Dr. Helena Ramirez, the team's lead behavioral ecologist, whispered into her recorder, "This is extraordinary. I've never seen a Komodo dragon choose prey that is clearly suboptimal in terms of energy gain. Something about this behavior is signaling adaptation, or perhaps a learning process we do not yet understand." As the dragon closed the distance, the lizard detected the predator and darted toward a crevice between rocks. Normally, this would signal the end of the chase. The Komodo dragon would abandon the small prey, conserving energy for a larger, easier target. But the dragon exhibited something astonishing persistence. It adjusted its approach, predicting the lizard's escape route and cornering it in a narrow opening. This tactical calculation left the scientists stunned. The Komodo dragon was not only deviating from instinct, but demonstrating a level of problem-solving and anticipation rarely documented in reptiles. The drama intensified as the lizard attempted multiple evasive maneuvers. It darted sideways, climbed rocks, and tried to use vegetation as cover, but the predator adapted at every turn. Cameras captured the chase in slow motion, revealing minute details of the dragon's muscular coordination, claw placement, and jaw alignment. Dr. Ramirez noted, "We are witnessing cognitive flexibility. The dragon is responding to dynamic variables in real time rather than relying solely on habitual hunting patterns." This is an entirely new insight into predator behavior in Komodo dragons. Suddenly, the chase reached a critical point. The dragon misjudged a leap over a fallen tree branch, causing it to momentarily stumble. For a second, the lizard had a chance to escape, and the team held their collective breath. But instead of retreating, the Komodo dragon recovered within milliseconds, snapping its jaws around the smaller prey with pinpoint precision. The scientists erupted in a mixture of relief and astonishment. They were witnessing the predator complete a hunt that initially seemed illogical, yet ended successfully, demonstrating an unexpected level of adaptability and skill. The aftermath of the hunt left the researchers analyzing more than just the kill. Questions arose. Why would a predator known for energy, efficient hunting expend effort on such a small target? Was this behavior learned, perhaps through experience or observation of other dragons? Or was it a sign of environmental pressures forcing Komodo dragons to diversify their prey selection as competition or habitat changes intensify? These questions would dominate discussions for weeks following the observation, challenging decades of assumptions about these apex predators. Moreover, the event offered critical insight into predator-prey dynamics within the ecosystem. By targeting a smaller, less typical prey, the Komodo dragon influenced not only its own energy intake, but the behavior of multiple species within the environment. This incident suggested that apex predators might play a more nuanced role in regulating biodiversity than previously understood. The choice of wrong prey was not a simple mistake. It was an ecological experiment unfolding in real time, providing scientists with invaluable data about adaptation strategy and survival in extreme conditions. Analysis and scientific reactions, rethinking predator behavior. In the hours following the unexpected hunt, the research team gathered to analyze the footage and notes from the field. What they had witnessed was not a typical predatory episode. It was a behavioral anomaly that challenged long-held assumptions about Komodo dragons. For decades, these apex predators had been portrayed as opportunistic but predictable hunters, selecting prey primarily for caloric efficiency. The observed behavior, however, suggested a level of intelligence, flexibility, and decision-making previously undocumented in reptiles. Dr. Helena Ramirez and her colleagues immediately began breaking down the event frame by frame. The first revelation was the dragon's ability to adapt to the lizard's evasive maneuvers. It was not merely relying on brute force or instinct, but appeared to anticipate its prey's movements. The dragon adjusted its body position, stride, and jaw alignment in real time, displaying a form of problem-solving that scientists rarely associate with reptiles. This raised critical questions about cognitive abilities in Komodo dragons, suggesting that intelligence and strategy might play a far larger role in hunting behavior than previously recognized. The team also examined the choice of prey. Traditional ecological models assume predators, like Komodo dragons, prioritize high-calorie targets to maximize energy efficiency. Yet, the dragon had expended significant effort to capture a smaller, less nourishing animal. Was this an isolated incident, a misjudgment, or evidence of learning behavior? Dr. Ramirez proposed that the dragon might have been experimenting with different prey options, testing hunting techniques, or responding to subtle environmental cues unknown to the observers. Why might be seeing an adaptive behavior that provides long-term survival advantages? She noted, perhaps targeting smaller prey in certain contexts improves hunting efficiency overall, or strengthens predatory skills in younger or less experienced dragons. The scientific community was stunned when the footage was shared at an international symposium on reptilian behavior. Many biologists admitted that this observation forced a reevaluation of predator-prey interactions in Komodo dragons. It highlighted that apex predators, even in highly specialized species, are capable of cognitive flexibility, adapting strategies based on immediate conditions rather than relying solely on instinct. Such insights have implications not only for behavioral ecology, but also for conservation strategies. Understanding the complexity of hunting choices can inform habitat management, prey population control, and strategies to maintain ecological balance on Komodo and surrounding islands. The research team also speculated on environmental factors that might have influenced the dragon's unusual choice. Human encroachment, shifts in prey populations, and climate variability could have created conditions prompting predators to experiment or adapt. By studying such anomalies, scientists gain a better understanding of how Komodo dragons, and perhaps other apex predators, respond to environmental pressures. These insights could be crucial in predicting how species will cope with ongoing habitat changes and ecosystem disruption caused by climate change and human activity. Furthermore, the event reignited debates about reptilian intelligence. Historically, reptiles have been considered instinct-driven and limited in their problem-solving capabilities. Yet this single hunt challenged that notion, suggesting that Komodo dragons can evaluate options, anticipate outcomes, and adapt strategies in real time. The observation offered a rare glimpse into decision-making in a species often dismissed as simple or primitive, proving that intelligence in the animal kingdom is far more diverse and context-dependent than previously thought. As the research team compiled their findings, the implications became clear. This one hunt, initially dismissed as unusual or insignificant, had opened a new window into the lives of Komodo dragons. It forced scientists to question textbooks, re-examine ecological models, and recognize the subtle, sophisticated behaviors of predators that survive at the top of the food chain. The world had witnessed a predator choosing the wrong prey, and in doing so, revealed lessons that would shape our understanding of animal behavior for years to come. Ripple effects, ecosystem impact, and prey behavior. The implications of the Komodo dragon's unexpected prey choice extended far beyond the immediate hunt. While scientists were captivated by the predator's unusual behavior, they quickly realized that this single event had cascading effects on the local ecosystem. Predators and prey are locked in an intricate dance of survival, and even minor deviations in hunting patterns can reverberate through food webs in ways that are not immediately visible. Immediately following the hunt, the smaller monitor lizard population exhibited a noticeable behavioral shift. Researchers observed that nearby lizards became hyper-vigilant, altering their basking habits and moving to more concealed areas within the rocky terrain. This change in behavior, known as predator-induced vigilance, is a natural response to heightened predation risk. Yet, in this case, it occurred in response to a predator targeting prey outside its typical selection range, which caused a ripple of uncertainty throughout the prey community. Smaller animals that were once confident in open areas now had to adapt quickly, influencing feeding patterns, territorial behavior, and even reproductive timing. The shift also had ecological consequences beyond individual prey. In ecosystems like Komodo Island, predator-prey dynamics are tightly linked to vegetation, soil quality, and smaller organisms' survival. When monitor lizards altered their movement and foraging behavior, the distribution of seeds, insects, and other small creatures they interacted with also changed. Researchers began noticing shifts in plant growth patterns in areas where lizards previously fed and moved regularly. A single hunt, which initially seemed inconsequential, highlighted how apex predators can indirectly shape entire habitats, not just through direct predation, but through the behavioral responses of their prey. Scientists were particularly intrigued by the indirect effects on other predator species. On Komodo Island, smaller reptiles and birds of prey often rely on predictable hunting patterns of larger predators. The dragon's unconventional choice introduced a layer of unpredictability. Researchers noted that other predators began adjusting their hunting strategies in response, exploring new feeding grounds or targeting different prey. This demonstrated that apex predators, through both action and unpredictability, influence not only prey populations, but also interspecies competition, resource distribution, and ecological balance. The event also sparked conversations about the adaptability and learning potential of Komodo dragons. By choosing an atypical prey, the dragon may have been experimenting or refining hunting techniques which could have long-term effects on its survival strategy. If such behavior is observed repeatedly across generations, it could suggest that these apex predators are capable of learning, adapting, and passing on hunting knowledge, an evolutionary advantage in an environment where food sources are limited or variable. Understanding these dynamics is essential for conservationists who aim to protect both predators and prey while maintaining the delicate ecological balance of islands like Komodo and Rinca. Beyond immediate ecological effects, the hunt offered a broader lesson in unpredictability within natural systems. Biologists and ecologists often rely on models that assume regular predator-prey interactions. However, this event underscored that individual decisions, even by a single predator, can disrupt expectations, creating complex, cascading consequences that ripple through the ecosystem. It served as a real-time case study, showing how even the apex predator's choices are influenced by a mixture of instinct, adaptation, and environmental pressures, and how these choices, in turn, shape the behavior of countless other organisms. Finally, the observation highlighted a crucial principle of wildlife research. No behavior exists in isolation. Even a seemingly minor deviation, a Komodo dragon attacking an unusual prey, can illuminate vast, interconnected ecological networks, revealing hidden patterns and unanticipated relationships. By documenting this event, scientists gained a rare glimpse into the complexity of predator-prey dynamics and the resilience of ecosystems facing change. Human response, conservation, research, and local impact. The unexpected hunt did not just ripple through the natural ecosystem. It also captured the attention of the human world, particularly the scientific community, conservationists, and local communities living near Komodo Island. Researchers were quick to realize that this observation challenged long-standing assumptions about Komodo dragon behavior, prompting a reassessment of conservation strategies, wildlife management, and even educational outreach programs. For the scientific community, the event represented a rare and invaluable opportunity. Field biologists and ecologists immediately convened to analyze the recorded footage, detailed notes, and ecological data collected during the observation. Dr. Helena Ramirez, leading the research team, emphasized that this single incident could reshape textbooks. What we witnessed is not an anomaly to be dismissed. She remarked in an interview, "It's a demonstration that Komodo dragons are capable of behavioral flexibility and problem-solving previously unrecognized in reptiles. This has enormous implications for our understanding of predator ecology and evolutionary biology." The findings also influenced ongoing research priorities. Scientists recognized the need to conduct longitudinal studies to determine whether this behavior was an isolated event or part of a broader trend among Komodo dragons. Additional tracking of both predators and prey, analysis of hunting success rates, and studies of energy expenditure became essential components of new research protocols. Funding agencies, initially skeptical, were persuaded by the groundbreaking nature of the observation, resulting in increased support for field research on predator adaptability and ecosystem dynamics in Komodo National Park. Conservationists were equally affected by the discovery. Komodo dragons are listed as vulnerable due to habitat loss, climate change, and human encroachment. Understanding their hunting behavior, including anomalies like the one observed, is critical for designing effective conservation strategies. If dragons are capable of adapting their prey choices, conservationists must ensure a diverse and healthy ecosystem that supports both typical and unexpected hunting patterns. This includes monitoring prey populations, maintaining natural habitats, and mitigating human impact to preserve the delicate balance that sustains these apex predators. Local communities also experienced indirect consequences. Komodo Island relies heavily on eco-tourism, and Komodo dragons are a major attraction. The discovery of this extraordinary behavior generated international media attention, attracting tourists, researchers, and wildlife enthusiasts alike. While increased tourism can boost local economies, it also brings challenges managing human-wildlife interaction, preventing habitat degradation, and ensuring that both the dragons and local livelihoods are protected. Park authorities had to revise visitor guidelines, enforce stricter safety measures, and educate tourists about the unpredictable nature of these apex predators. The scientific and public interest in the event led to collaborative initiatives between researchers and local communities. Educational workshops were organized, teaching residents and park rangers about the nuances of Komodo dragon behavior and the importance of monitoring ecological changes. Citizen science programs were launched, allowing locals to assist in observation and data collection, which helped expand the scope of research while fostering a sense of shared stewardship over the unique environment. Furthermore, the observation highlighted a broader lesson for wildlife conservation worldwide. Flexibility and unpredictability in predator behavior must be considered when developing management plans. Conservation strategies cannot rely solely on established assumptions. They must be dynamic, adaptive, and informed by real-time observations of animal behavior. This Komodo dragon hunt demonstrated that even apex predators are capable of surprising behavior, emphasizing the need for continual observation, documentation, and reassessment in conservation science. In essence, the event bridged the gap between observation and action. By capturing an unusual hunting episode, scientists not only advanced academic understanding, but also influenced conservation policies, research agendas, and local community engagement. It became a case study demonstrating the interconnectedness of ecological systems, human activity, and the importance of preserving both predator and prey populations to maintain ecosystem health. Long-term implications. Lessons from the unexpected hunt. The unprecedented hunt observed by the scientists did more than challenge assumptions. It left a lasting imprint on the way researchers, conservationists, and ecologists understand apex predators, ecosystem dynamics, and the unpredictable complexity of nature. What initially seemed like a bizarre and inexplicable behavior became a cornerstone for long-term study, influencing scientific approaches, conservation strategies, and educational programs around the world. One of the most significant implications lies in the study of predator adaptability. Traditionally, apex predators like Komodo dragons were thought to rely almost entirely on instinctual behavior honed through evolution. But this single hunt suggested that these reptiles might possess a surprising degree of behavioral plasticity. By deliberately selecting a prey species outside their usual range, the Komodo dragon demonstrated problem-solving abilities, persistence, and a form of strategic thinking. Over time, these observations could redefine what scientists consider possible in reptilian cognition and learning, challenging the old perception of reptiles as simple, instinct-driven creatures. The event also highlighted the importance of studying individual variability within species. While textbooks often describe species-level behaviors, real-world observations reveal that individual animals may deviate from these norms. In this case, the dragon's prey choice provided insights into adaptive hunting strategies that could vary depending on age, experience, physical condition, or environmental pressures. By incorporating these nuances into research, scientists can develop a more sophisticated understanding of species behavior, leading to more accurate ecological models and predictions. Ecologically, the hunt revealed how single events can have cascading effects throughout the environment. The unusual